Well, today we will see human-to-machine interfaces because an important phase uh, of human-computer interactions or human-computer interfaces, user satisfaction, or simply end users computing satisfaction because of human-computer interaction study. A human and a machine in a communication draw from supporting analogy on both of the machine and the human side. They also sometimes termed as human-machine interaction, man-machine interactions, or computer-human interactions. Smooth communication between peoples and the machines require interface, the place where or action by which the users engage with the machines. Simple examples are light switch or the pedals, steering wheel in a car. However, a system can also be controlled by text being keyed in a mouse, touch screens, or voice or gestures. Human machine interaction is with industrial plant and other dynamic technical systems has nowadays been recognized as essential for process safety, quality, and efficiency. It comprises all aspects of interactions and the communication between human users and their machines via human-machine interface. Organizational and cultural aspects are strongly involved with human-machine systems. Research has now been performed for about 16 years. Nevertheless, it took quite some time before the human-machine system will become established and more widely accepted disciplines, particularly also in industries. For a long time, mainly the aeronautic and astronautic industry, and to a lesser extent the car manufacturing industry showed some more interest. This situation has now totally changed. It has been recognized that good symbiotic between human and the machine is generally required. The Association for Computing Machines defines human-computer interaction as a discipline concerned with the design, evaluations, and implementation of interactive computing systems for human use and with the study of major phenomena surrounding them. The whole system of human users, human-machine interface, and the machine is so-called human-machine systems. Different human user classes may be involved, like operators, engineers, maintenance person, and the managers. They have different but overlapping information needs. The term machine indicates any kind of dynamic technical system or real-time applications, including its automations and decision support, equipment, and software, and it relates to many diverse application domains. The automation component of the technical system are donated as supervision and the control system. They interact directly with the poor technical production process. Examples of such process are power generation process, chemical or discrete parts production process, aircraft, telemanipulators, or real-time software applications. The decision support system are more advanced, knowledge-based functionality of the machine which provide advice for the human users. The application domain include all kinds of industries, transportation, medical service, home, and entertainment systems, where all applications domain profit from advancement in the development of the human-computer interaction fields. Human-computer interaction is characterized as human interaction with those computer application domains which are not determined by dynamic process or by real-time constraints, as it is always the case in human-machine interactions. The degree of automation in control dynamic technical system has substantially been increased over the last decade. This is true for all technical systems such as power plants, industrial production plants, and vehicle and transportation systems. High level of safety, performance, and efficiency have been achieved by means of the increased use of automatic controls. Interestingly enough, however, with no surprise to human factor specialists, the need for improved human-machine communication increased rather than decreased with the increased degree of automations. Generally, increased automation does not replace the human users who are interacting with the machine, but shifts the location of the interface between both. The machine as an automated system become more complex than with less automation, leading to more sophisticated structure of supervisory control, higher complexity, and a more sophisticated control structure requiring equality of communications and cooperation between human and the machines. The role of human user shifts from that of the controller to that of the supervisor. The human supervisor interacts with the processor, one or more several layers of computers on which the human-machine interface, the automations, and the decision support functionality are implemented. Thus, the functionality of well-designed human-machine interaction have gained predominant importance in advanced process control as a consequence of the degree of automation and also of the increase of extended automation functionalities. The advanced technology with extended functionality include expert systems for control and diagnostic, physics process control, and artificial neural networks in process control. It is important to ensure integration between conventional control systems and these advanced technologies for purpose of reaching overall goals of efficiency and safe systems performance as well as sustained and satisfying human performance. Matching the effort of automation of human factors issue lead to the approach of human-centered automation recommended by many researchers for quite a long time. Today it is also more and more followed in industry under the perspective of human-centered automation and human-centered design. Human-machine interaction appear to be symbiotic process between the human users and their machine via human-machine interface, whereby both machines and the interface have properly been designed. The functionality of both the machine and the interface have to be specified and designed with a strong view on human-centeredness with respect to user orientations concerning human cognitive process, human needs, and human capabilities, and based on goal orientations and task orientations. Then, this functionality can be implemented as extended automation modules and a knowledge-based decision support system within the machine and as interaction and the communication module with the human-machine interface. Computer graphics, multimedia, and multimodal displays as well as knowledge-based and other software technology offer a wide range of alternative design for human-machine interface, extended automation, and knowledge-based support. Human-machine interaction is a goal-oriented. The overall goal of human-machine systems are mainly productivity goals, safety goals, humanization goals, and environmental compatibility goals. The productivity goals include economic as well as a product and production quality goals. The importance of the safety goal is strongly influenced by the application domain. This goal class dominates all other in many large-scale systems and particularly in risky systems. The humanization goal comprises team and work organization, job satisfaction, ergonomic compatibility, and cognitive compatibility. The latter includes the sub-goal of transparency and human understanding. The environmental compatibility goals refer to the consumption of energy and the material resource as well as the impact on soil, water, and air. Human-machine interaction, human-machine system research requires multidisciplinary or interdisciplinary view and approach. Due to the multidisciplinary nature of human-computer interface, people with different backgrounds contribute to this success. Humans interact with computers in many ways. The interface between human and computer is crucial to facilitate these interactions. like desktop application, internet browsers, handheld computer can make use of the prevalent graphic user interface, like of today voice user interface, speech recognition, and synthesizing systems. The following three domains contribute to human-machine interactions and system researches: cognitive science and ergonomic as the human science, automation and system engineering as the system science, and information and communication engineering as the computer science. Good human-machine interaction and the system design have gained high market value for almost all products and services. Consequently, strong need industry and the society today is an important application for this influence the human machine system fail which become mature but continue at the same time as an innovative and always further developing research area. Poorly designed human machine interface can lead to many unexpected problems. A classic example is 3 Mile Island accident in USA, nuclear meltdown accidents. Accidents in aviation have resulted from manufacturers' decision to use non-standard flight instruments where investigation concluded that the design of the human-machine interface was at least partly responsible for the disaster. How it works. A very broad spectrum of control functionality as possibilities of control input in human-machine interaction exists. Different form of control can be exerted either direct, like gesture as with conductor of an orchestra, via biosignals, or via control devices. Control via biosignals is a particularly valuable handicapped pupils in the operation of arm process. Speech and motion displacement force and gesture can be used directly or via control devices. Speech inputs and gesture control will eventually become new means of control in the future. A few operational systems are already in the use. Speech recognition allows automatic interpretation of the human voice based on models for phenomena which are the small unit of sound in any word and sentences. This technology has great potential for human control of computers and machines once the recognition rate and the speaker independency can be further increased. Gesture control has been developed with the music technologies and in engineering. Currently, it is an emerging subject of research including gesture sensing, capture technologies, intentions, emotion detections, map strategies, and etc. The predominant form of control in human-machine interaction is the one using control devices. Important type of control devices are keyboard with alphanumeric or functional key, mouse, joystick, trackball, steering wheel. Force displacement characteristics of this control device need to be appropriately designed. Also, some virtual control devices exist which can be operated on display screen, buttons, lights, and main options. Eliza, for instance, the first chatbot was invented in the 1960s but soon ran up against this limitation. It couldn't answer follow-up questions. Modern chatbots work with artificial intelligence in customer service, give written or spoken information on departure times or services, and they reply on the basis of programming rules and routines like Google Home, Google Assistant, are also a chatbot. They all learn from the request and thus expand their repertoire on their own without direct intervention by a human. The more chatbot understand, the better the response. The closer we come to communication that resembles conversation between two people. Big data also play a role here. If more information is available to the bot, they can respond in a more specific way and give more appropriate replies. Gesture control, voice recognition also have share on this aspect. This is all about human-computer interactions. Thank you. Well, today we will see human-to-machine interfaces because an important phase